Hi, Chuck McCown here. I'm on top of the local Lake Point Water District water tower with one of our new products that we're going to be doing a little bit of semi-destructive testing on it today. So let's see how it goes. But we're out here in the Mountain West where we don't have these kind of water tanks in most places because we got mountains and we build reservoirs up on the side of hills. But this is the best I can do to represent one of your Midwest water tanks. And this is a magnetic mount, and we're trying to figure out how much force it takes to pull this thing off the side of a water tank. Now I'm a 200-pounder, but I'm kind of spreading my weight out here a little bit. We're going to do some testing with some dynamometers and find out for sure. All right, here's one of our first pieces of test instrument. This guy's one of the guys that actually builds a lot of this stuff. This is Ben McCown, and he's doing the first bit of load testing here. I think I can probably make him come off if I put my 200 pounds on there with him, but anyhow, we're going to get a little more scientific in that in a few minutes. All right, so today we're kind of one step down from the Jackin' with Jacks video where I actually had that super high quality Walmart scale. It was a dial scale that recorded the highest point. I don't know, I can't find it today, so I'm using this other high quality piece of gear here, but it doesn't have any recording device in it. So that's what the video is for. We can all watch it. And I'm just going to step on this here until hopefully I don't end up having some memorable fail, YouTube fail. And I'm just going to put some weight on it. And hopefully I'll be able to feel it start to give before it comes off in my face. Whoop. Well, I don't know where it was, but it was somewhere between 120 and 160. So there you have it in that axis. Now we're going to reset and pull it this way and then pull it off sideways. Okay, we're going to go in the other axis, but it's a little bit easier to use some power machinery to get that going. You can see we preloaded it to about 35 pounds. We're going to slowly pull up on it until it starts to slide around. So here we go. Oh, it's sliding, whoa. Do that again. See if I'm gonna watch the magnets now. It's about 80, I think, really, when it first started to slide. Okay, now we'll try it. We're gonna pull it off in this direction. All right, horizontal. I'm gonna watch the magnets as he puts some load on it. You guys watch the needle. Whoa, whoa, whoa. So I think that was probably 40. That's clear out here at the end. Now let's repeat these over here where it's the strongest. All right, should go up a little bit higher this time. Let's pull it back and see what happens. Well, it was more than 40. I don't know how much. It's kind of a static load on there right now. So we'll pull it in the vertical direction again from this same spot. I'm going to go upward at a little bit of a stronger spot here. Let's see what happens. Whoa. I don't know where it started moving because I wasn't watching the scale, but I'm assuming it was up around 80 here in the middle. So, and then you saw him hanging off of it in the middle. So we're 150 pounds in this direction. So I think that's pretty good. We can go with higher strength magnets. Well, these magnets are crazy strong. We're using actual kitchen utensils to put them on the tank. We'll put a spatula on the tank and put the magnet down on the tank, and then we'll tip it up and slide the spatula out. These magnets want to suck right in the last quarter of an inch, and you don't want to get any fleshy bits between you and the tank. So if somebody needs more strength than this, it's just a matter of buying stronger magnets. The place I buy these magnets from has a magnet that's about, I think it's about 4x4x3 or something like that. It's got 500 pounds of force. These magnets are like 120 pounds of vertical lifting force. So it's actually more the friction and the spherical nature of the tank, you know, how flat. This is actually probably a worse test than on a municipal water tank, because the radius here is a little bit more pronounced than you'd find on a typical municipal water tank, I think. So the flatter it is, the more it's going to hold on. I mean, if this was stuck down on a flat plate, which we really probably ought to do that test, you're going to see these numbers go quite a bit higher. But this is the very first prototype, and I'm pleased with it. I think this can be used for a lot of applications. And then I'm going to go include a little bit of numbers here about, you know, 1 square foot flat plate, what it loads it at 100 mile an hour wind or 90 mile an hour wind or whatever. There's some really definite curves. I think it's the EIA 222C curve or something like that, but I'm going to show you that. Okay, here's the formula. If you really want to calculate it yourself, you can get your force applied with this formula, but I've worked it out here for you. And it shows that, you know, at zone A areas, the 86.6 peak gust, 30 pounds of force in any direction, it's not going to pull this thing off. Even at 40 or 50, you saw it yourself, went up to 80, but use a safety strap on it.